Okay, so today's lesson is really solving logarithm equations. So basically we're solving for x, right? Some of this can be done pretty easily with the calculator, okay? What I put back up on top here is something we just keep talking about over and over again, and that is changing things from log form into exponential form and going back the other direction, okay? We've talked about that before, but it's handy to have it up there, okay? So if we've got log of some base of an answer equals an exponent, it can be transposed into the base to the exponent equals the answer, right? And we're going to need to use that today, okay? So let's take a look at example A, okay? Solve each. So what I want to do is this. To solve for 5 to the 2x, anytime you want to solve for an exponent, that's why we have logs. Logarithms are all about solving for the x. So let's change this into log base 5 of 125, right, equals 2x. Okay, that was easy, right? This is 3, but if you're not sure that it's 3, you can use your calculator, right? I mean, you know how to do the log base. I mean, it is 3 because 5 to what power equals 125. But you could go and say, well, let's just use my math. Thanks to Evan, we have the log base button, right? Yay, Evan. I know. So we go log base 5 of 125. And what do you know? Well, we get 3. Kind of thought we'd get 3. So this log base 5 125 is 3. 3 equals 2x. Divide by 2, and I get 1.5 equals x. Okay, thumbs up? Good. All right. B is the same way. All right, so first let's change it into log form. Okay, so let's go log base 3 of 7 equals x plus 2. I can't do that in my head. Log base 3 of 7 is some decimal. So I'm going to use my calculator. Okay, so I'm just going to go and use the Evan button. Let's just call it the Evan button. All right, we'll go log base 3 of 7. And I get about 1.77, okay? So I got about a 1.77 equals x plus 2, right? Subtract 2, minus 2, minus 2, and I get about a negative 0.228. Negative 0.228. Oh, slide over. Hold on.
Wait.
There it is. There it is. Negative 0.228. Thumbs up, you guys? Pretty easy, right? Pretty easy, okay? C, same kind of thing, not too hard. Before I do anything, though, I'm going to tidy it up. Let's just get rid of the 8. Okay, let's get rid of the 8 before we do anything. So how do I get rid of the 8? Divide. Divide by 8. Divide by 8. So 20 divided by 8, what's that, 5/4? 20 divided by 8 is, 2.5. So I've got a 2. I've got e to the 2x equals 2.5. Okay? Now, a little bit, slide it over for a little bit of side work. ln of e is always equal to 1. In fact, I'm going to put a box around that and highlight it, okay? ln of e is always equal to 1. Always. And it makes sense because of base e, okay? So when I change this to log form, we're going to want to use ln. Does that make sense? We're not going to use regular log. We're going to use ln. So I'm going to go straight to ln of 2.5 is equal to 2x. Is equal to 2x, right? And then what's ln of 2.5? I don't know. So calculus made for it. ln 2.5. We get about 0.916. So we get about a 0.916 equals 2x, right? This isn't too hard. You guys agree? Divide by 2, and x is equal to, divided by 2, about 0.458. Not too bad? Okay.
To the left a little bit.
Yeah, sorry about that, sky that way.
Yep, that's
There
good.
you go. Yeah. D. D's gonna be a challenge, but we can do it. Okay. All right. What if, and I know how to tackle this problem, what if I wrote this instead as x squared minus 1x minus 6 equals 0? So what I'm really doing in this is I'm going to let e equal x, so that I've got e squared makes an x squared, okay? So if I do that, let's see how to describe this, okay? If I have e to the x and I square it, okay? Let's do it this way, okay? E to the x squared. So when you take an exponent to an exponent, you multiply, right? And so then e to the x squared is the same thing as e to the 2x. So what I'm doing is letting my x, letting this value be e to the x, okay? So in this case, we're gonna let, can you see that? It's a little tricky, it's a hard one. So we're doing it here is I'm gonna slide this up above because I'm running out of room. So I'm letting my x equal my e to the x, okay? So x is equal to e to the x, okay? So it's writing, instead of writing, and then I square it. So writing e to the x, I just wrote x squared, okay? Now this will factor, right? X minus 3, x plus 2 equals 0. And then what I get is x equals 3 and x equals negative 2. That's easy. Now,
Wait,
look.
could you speak up a little bit?
Yeah.
Did you let X?
Oh, yeah, I put it here. I zoomed it too far in, didn't I?
Yeah.
But then I can't, once I start recording, I can't change it. Like I tried to change the
Wait, what?
contrast to, it gets locked in. Once I start recording, I can't change anything. I can't change the zoom. I can't even change the contrast. Okay, now, what do we let x equal? We let x equal e to the x, didn't we? Okay? So instead of writing x, we're going to put back in e to the x, okay? So we'll rewrite this. Instead of x, we're going to rewrite this as e to the x equals 3. And we rewrite this as e to the x equals negative 2. How am I doing? This is a hard problem. So then I've got to change this to ln of 3 because I changed it from exponential to log, and I got to do this as ln of negative 2. I'm going to throw this one away because it's impossible to do logs of negative numbers, and ln of 3 is some decimal answer. ln of 3. 1.09. How about 1.1? How's that? 1.1. Okay, and we'll practice that one again tomorrow. How's that for a deal, huh?
Oh, yeah.
Yeah, we'll definitely have to practice that one. Okay. Okay. E. All right. Well, I think I see a possibility of doing some common factoring. Okay. So what do they have in common? So if I take out an e to the x, right? If I take it out an e to the x, then I'd have a 3x plus x squared equals 0, okay? How's that? So then I've got an e to the x equals 0, and I've got a 3x plus x squared equals 0, okay?
You can't see it.
Wait, I'm so confused. Oh, there we go.
I am so sorry, you guys. Will you help me out on this? Because I'm looking at the screen here, and I'm not seeing up there, okay? I zoomed it too far in, didn't I? Yeah.
It's okay.
All right, so I common factored out an e to the x, right? And I've got e to the x equals 0, and a 3x plus x squared equals 0. Okay, now I'm going to throw this one away. Because if I go ln of 0, it's impossible. Impossible. Plus, there is no exponent that'll make anything equal 0. It can never equal 0. Remember the graphs? They don't equal 0, so throw that one away. Here, though, I can common factor out an x. I have a 3 plus x equals 0. If I do my many equations here, I'll have two answers, x equals 0 and x equals negative 3. Now, negative 3 actually can work. You'd think we got to throw away the negative 3, okay? But we can actually keep the negative 3 on it, and I'm going to show you why. If I go back to the original problem, I'm not plugging negative 3 into logs, am I? Okay? So the negative 3 is okay. I'm not plugging it into a logarithm, I'm just plugging it into x's, okay? So negative 3 is okay. You just can't put a negative into a log. Okay? All right. F. Okay, there's two ways to do f. The easy way and the hard way. I'm going to do the easy way, okay? Why not? I can make that into a 2. I can make that into a 2. So 16, what is 16 as a 2? 2 to the power of 4, right? So 4 is right. So we're going to have a 2 to the 3x plus 1 equals 2 to the 4th, or 4x, okay? Now, if it's 2 to something, then just by pure logic, the 3x plus 1 has to equal to 4x. Does that make sense? Has to. Just make this pure logic. I can prove it to you, but do you agree that in this case, 3x plus 1 has to equal to 4x? So cancel, cancel, and you got a 3x plus 1 equals 4x. We'll just solve. Minus 3x, minus 3x, 1 equals 1x, or x equals 1. Thumbs up. We're going to have fun doing homework together, aren't we?
Yeah.
Yeah. Should we turn the page?
You
I'll wait. You bet.
Thank you.
I like these. These are fun.
Thank you.
Everybody got it? Okay, turn the page. All right. Now, these are log equations. So before we do anything, we've got to make sure that we know that that x, if you have log of x, x must always be greater than 0. Okay, so whatever answers I get, a little side work, whatever answers I get, I've got to double check. So I've got to make sure I do a check when I get an answer. It can't be 0 and it can't be negative. Does that make sense? Log of 0 doesn't exist and log of negative numbers don't exist. So when you get an answer with logarithms, you got to go, oh, wait a minute. If it's 0 or negative, we might have to check it, okay? All right, so you ready? Slide it over. All right. So when I solve log equations, the biggest thing for me is to get rid of the log. Just get rid of the logarithm. Well, that's easy. I'm going to go 2 to the 3rd power equals 25 minus x. I changed from log form to exponential form. 2 to the 3rd is 2 times 2 times 2, which is 8, is equal to 25 minus x. Okay? Minus 25 minus 25. Negative 17 equals negative x, right? Or x is positive 17. Okay, so I'm going to check. With logarithms, I always check my work, so I'm going to put a little star up here, my standard. Make sure you check answers, okay? Got to check answers because some of my answers aren't going to work. So if I just check it really easily, keeping in mind that this can't be 0 or negative. So if I put 17 in here, I'm okay. Agreed? I'm going to have a positive number of an 8. I'm okay with that, okay? This one works. Circle it. It's good. Okay, B. B's not hard. There's just some extra numbers hanging around. There's just some extra numbers. Let's get rid of the extra numbers, okay? So what's the first extra number you want to get rid of?
4.
Yeah, let's go minus 4. Minus 4. I got a 3 log 2x equals 12, right? We got another extra number hanging around. Let's get rid of that one. Let's divide by 3. Divide by 3, and I got a log of 2x equals 4. How am I doing? Okay, I want to get rid of the log. I got to change it to exponential form. But there's an invisible base. What's my invisible base? 10. So let's bring the invisible base back in, and let's change it. 10 to the fourth equals 2x. Okay, so we'll go 10 to the fourth power equals 2x. 10 to the fourth power is 10,000. 1, 2, 3 equals 2x. Yeah, thank you. Yeah, help me out, you guys. I shouldn't have zoomed in so far. Divide by 2 and I get 5,000, right? Okay. And if I do a real quick check on my answer, I think I'm okay. If I put 5,000 right in here, I'm going to be all right. You guys agree? Positive number. It's not 0. I'm good to go, okay? Sorry. I'm going to circle it. I like that answer. It's a good answer. Okay. All right, here comes the fun stuff. You ready for the fun stuff? This is what we did last night on the last two problems. So C is a lot like problem number 38 on last night's homework, okay? So the first thing I do is I got too many logs. There's too many logs, so let's bring it together. So if it's plus here, we're going to bring it together as a single log as multiply, okay? So I'm going to rewrite this as log of x plus 2 times x equals log of 8. How am I doing? Or I'm going to get log of x squared plus 2x equals log 8. Okay? Now, seems to make sense to me that log of something equals log of something, and the somethings need to be equal. Okay, I'll say it again. I got log of something and log of something. It seems to me that what's inside need to be equal. Okay? So, technically you can't do this, but if you cancel out the logs, it kind of makes sense. I can prove to you why I can cancel them out, but you probably don't care. So then I'm just left with x squared plus 2x equals 8. Looks like a factor problem, huh? Bring over the 8. X squared plus 2x minus 8 equals 0, right? How about positive 4, negative 2? Positive 4, negative 2. X plus 4, x minus 2 equals 0. Many equations, x equals negative 4, maybe not, and x equals 2. Now, why did you say maybe not on the negative 4?
Might be negative.
Yeah. Thank you, Sky. So if I go back and take my negative 4, if I put my negative 4 right there, I'm in trouble. You guys agree?
Yeah.
So throw it away. Throw away the negative 4. The 2 is going to work, though, right? Throw it away, okay? But we'll circle the 2 and we'll keep the 2, okay? All right, last but not least, D. All right, again, I've got too many logs. I got too many logs. If I want to solve, I got to bring them together to make a single logarithm. Okay, thank you, Zoe. Okay, I got too many logs. Let's bring it together and rewrite it as a single log. So I'm going to go log of x plus 2 times x minus 1 equals 1, okay? Which is log of x squared plus 1x minus 2 equals 1. Now I foiled in my head because I think you guys can do that too. Pretty sure that you're that smart. I got a negative 1x, positive 2x makes a 1. I mean, this is pretty tough. You're not dummies. You're not. But you guys see I got the 1, right? Negative 1, positive 2, right? Skip a step, right? So then I got to get rid of the log. How am I going to get rid of the log? What's my invisible base? 10. So what am I going to do?
10.
Yeah.
Power of x plus 2.
10 to the power of 1.
Equals x plus
X squared plus 1x minus 2. Okay, good. Okay, 10 to the power of 1 is just 10, right? So we're going to have to factor. So if I bring over the 10, I'd have to subtract 10, right? Minus 10. Minus 10, let's see what I got. Okay, I got a 0 equals x squared plus 1x minus 12, right? Factor, factor. Right? Scoot it up. There you go. How about a positive 4, negative 3? Positive 4, negative 3, right? X plus 4, x minus 3. Many equations, what do I get? Negative 4, probably not, right? And then x equals 3. So let's double check the negative 4. Okay, I'm probably going to throw it away. Go back to my original. Yeah, if I put -4 right here, I'm in trouble. You guys read it? Even if I put it here, I'm still in trouble, right? So I throw away the -4, and I think the 3 works, and there we go, okay? So I'll circle our answer. Okay, how is that? And the cool part is we really do have enough time to get some homework done today, right?